We will continue with complex numbers in rectangular or Cartesian form. The objective of the video is to perform multiplication of complex numbers in rectangular or Cartesian form. Say I'm given two complex numbers z1 and z2, and I would like to multiply them together in this way. The first thing I'll need to do is to write down the complex numbers and side by side, like this. After that, I'm going to apply the distributive law of multiplication to open up the brackets. So first, I'm going to start with the term x1, and I'm going to multiply x1 to x2. So that leaves me with x1 times x2. Then I'm going to keep x1, but now multiply it to the second term. So I have plus j x1 times y2. Next, I'm going to apply the second term in the first pair of brackets, jy1, and multiply it to the first term here. So what I get is plus j x2 times y1. And finally, taking the same term, I'm going to multiply it now to the second term over here. What I have is plus j times another j, y1 times y2. So I have finished the distributive law. Now let's tidy things up. So x1 times x2, there's nothing I can do about it. I'll just copy down. Over here, plus jx1 y2 plus jx2 y1, since they both have j attached to it, I'm going to write down it as plus j and then apply a pair of brackets where the inside will be x1 y2 plus x2 y1. Now let's look at the last term. J times j is j squared. Let's continue. Let's copy whatever was written earlier. Nothing I can do about them, so I'll just copy. Recall that j squared is negative 1. Hence, this last term here will become negative y1 times y2. Now, at this point, I realize that the first term x1 times x2 and the last term negative y1 times y2 are actually both real parts because you don't see any j attached to them. The middle part here is the imaginary part because you have a j here. So what I'm going to do is I'm going to put the two real parts together side by side. And then I'm going to leave the imaginary part to the last term. So this is how you perform multiplication of complex numbers. You basically open up the brackets by applying distributive law and thereafter simplify the expression by grouping the real parts together and simplifying them and the imaginary parts together and simplifying them. So let's try this example. I am to find this times this. So I have two complex numbers and I would like to multiply them together. So as mentioned just now, I'm going to apply distributive law. I'll start by multiplying 3 to 5. So 3 times 5 gives me 15. Then taking 3 again, I'm going to multiply it to this term. So I have 3 times minus j3. That will give me minus j9 because 3 times 3 gives me 9. Let's continue with this term now, j2. j2, I'm going to multiply it to 5. So I get plus j10. Now this is because the 2 times the 5 will give me a 10. And the j remains. And finally, take j2 and multiply to the last term, negative j3. So I get negative j times j gives me j squared. 2 times 3 gives me 6. Okay, let's tidy things up a little bit. I have 15. And I have then these two terms containing j. So these are the imaginary parts. I'm going to put them together by writing plus j with a pair of brackets First term being negative 9, second term being plus 10. Negative 9 comes from here, plus 10 comes from this one. And then, remember that j squared equals to minus 1. So over here, the last term will become minus 1 times 6, because j squared has been changed to minus 1. Let's continue to simplify. So 15 remains, plus j, minus 9 plus 10 will give me 1. Over here, negative times negative 1 will give me positive 1. And multiply to 6, I get 6. Now this 15 and this 6 are real parts, so let's add them together. 15 plus 6 is 21. So this is my answer of the multiplication, 21 plus j. Let's try another one. I am to find 2 plus j, 3, whole thing square. Now the idea of a square means I take the term 2 plus j, 3, and I multiply it again to itself. So this is what square means. So I'm going to apply distributive law of multiplication. I'm going to start by taking the 2, multiplying it to 2 here. So 2 times 2 will give me 4. Then take the 2 again, but multiply it to the next term. 2 times j3 will give me plus j6. That's because the 2 multiplied to the 3 will give me 6. And the j remains. Next, I'm going to distribute j3 by multiplying it to this term. So j3 times 2 will give me plus j6, because again 3 times 2 gives me 6 and the j remains. And then multiply this to the last term. J times j will give me j squared. 3 times 3 will give me 9. The next step is to simplify. So I'm going to write down 4 and then j6 plus j6. Since these two are imaginary parts, I'm going to group them together. So I have plus j bracket 6 plus 6. How about the last term? Recall that j squared equals to negative 1. So I'm going to replace j squared with negative 1. So I have 4 plus j, 6 plus 6 is 12. And over here it becomes negative 9. This 4 and this negative 9 can be simplified into 4 minus 9, negative 5, plus j12. And this is my final answer. Now I'd like to bring to your attention that if I have a complex number z, where z is x plus jy, and I have its conjugate, which is x minus jy. Now remember that when you conjugate a complex number, you just need to change the sign of the imaginary part. If I were to take z and multiply to its own conjugate, my final answer is always a real number. That means the final answer should not contain a j. I'm going to prove it to you. So I'm taking z and multiplying it to z conjugate. So what's z? Z is x plus jy. And what is z conjugate? X minus jy. And I'm going to apply the distributive law of multiplication. So x times x will give me x squared. X times minus jy will give me minus jxy. Next, I'm going to distribute this. Jy times x will give me plus jxy. Jy times negative jy will give me negative j squared, because j times j, y squared, because y times y. Now, you realize that x squared remains, and these two will basically cancel each other out. So I'm left with x squared minus j squared y squared. Again, j squared is negative 1. So let's replace j squared with negative 1. Negative negative 1 is positive 1. And that is my answer. Notice that my final answer does not contain any j, which is in line with what we just said. When you multiply a complex number with its conjugate, you always obtain a real number. So let's check this out. I have 3 plus j4 and 3 minus j4. You notice that this is z and this is its conjugate. So I should expect a real number at the end. But let's apply distributive law and see whether I really do get it. So let's just perform the multiplication as we usually would. So I'll take the 3 and then multiply into 3. So I get 9. Take the 3, multiply into negative j4. I get negative j, 3 times 4, 12. Next, I take j4 times 3. So I have plus j, 4 times 3, 12. And finally, this. j4 times negative j4 will give me negative j times j, j squared, 4 times 4, 16. Again, we know j squared is negative 1. So what we have is 9 minus j12 plus j12 minus negative 1 times 16. Now these two basically cancel each other out. So my final answer will be 9 plus 16, which is 25. You see that there's no j. It's a pure real number. Time for a quiz. What is this? Since this is a complex number multiplied to another complex number, let's just do distributive law and open up the brackets. So, take the 2, multiply into 1. So 2 times 1 gives me 2. Take the 2, multiply 2 plus j. So 2 times plus j is plus j2. Next, I'll take minus j and multiply to 1. Minus j times 1 is minus j. Next, take minus j and multiply to plus j. I get negative j times j, j squared. Because j squared is minus 1, so it simplifies to 2 plus j2 minus j minus, let's replace j squared with minus 1. Minus minus becomes 1. So now let's just add the real parts together. So 2 plus 1 becomes 3. And the imaginary parts, I'll take the j out, bracket 2 minus 1. And so the final answer is 3 plus j.